So, is this thing recording? Yep. All right. Clean this up a little. So we did this a couple of days ago, playing around with a movie survey that I had started. Some other information that'd be nice to have in here are the standard statistics. So we already have, let's see, we have a partial count. We need a full count. What else do we like to know? We like to know the min, and in order, like Q1, the median, what's the next one? Q3, nice, you guys are catching on, and the max, and then the mean would be great to know. What's another word for the mean? Average, you guys rock today. AJ, you've been doing homework? Oh, good, all right. And then the standard deviation, STD, if you don't like to write much. Okay, so we're gonna do all those calculations, or I'm gonna do them, and then we'll use them. And we're going to make two pictures based on this. We're going to make this histogram on our paper, and then underneath the histogram, using the number line for the histogram, we're going to draw the box plot based on these numbers. Okay, so let me start collecting the data. So I want my count, and I'm pretty sure I only have movies in there, so it's safe to click on the column. 38, is that what the sum of the counts here is? Just to double check. Okay. And then what's the command for min? Anybody remember? It's just min, yeah, there we go. Or we could use the quartile command, option 0. So I'm gonna use min. Oh, you wanna see a cute trick? Check this out. So the min is quartile 0, right? Quartile 1 is quartile 1. The median is which quartile? Quartile 2, quartile 3, and the max is 4. So what you do is, next to where you want to do the min, Q1, median, Q3, and max, you type the numbers 0, 1, 2, 3, and 4. And then you go over here for the quartile command. And it turns out doing this, you only have to type the quartile command once when you do this trick. So I say, okay, where's my data? I go over here and grab my data. Now, if the data is all in one column, it's way easier. If it's not, then that means you're going to have something like what, A1 through A30 something. Stop it. A1 through A39 would be this data. I'm going to fill this command down, which means I would need to sneak in some dollar signs. Oops, stop it. So that makes it trickier, having to sneak in the dollar signs. Because again, if I fill the quartile command down, it would then shift these references down, and that would be a problem. Okay, so it works way easier if you don't have to worry about that. If you can just click on, oh gosh, I'm messing this all up. The column heading. All right. So if that works, good. And then what you do is just say for the next, I'm having all kinds of mouse problems. Okay, click, comma, click, close parentheses, enter, and then fill down. And bang, you have all your quartiles. Okay, so since I messed that up 3 times, let me try it again, make sure I can do it right. So if you have all your data in one column, and you type 0, 1, 2, 3, 4 for your min through max, you just type your quartile command until you get the min, highlight your data by clicking the column, comma, and then click the quartile number you want at that instance. And then when you fill that down, it's going to change the I4 to an I5, and then an I6 and I7, so it'll grab the right quartile. So I just hit enter, click back on it, fill her down, and I get all the quartiles in one quick shot. It's kind of a cute trick. Right. Anyway, mean, how do I find the mean? Yep, excellent. So I can do an average through that, would be another way. We'll do the way you said in just a minute for a different set of data. And again, since it's just the numbers in there, I can just click on the column. Standard deviation, there's a bunch of different ones. You either want STDEV or STDEVA. On Excel, there's another option called .s. That works too. Because generally we have a sample, not the whole population. Okay, so there's all my numbers. So these are the common things that are called one variable statistics. People calculate those all the time. So here's what I need you to do based on the stuff we just did here and some earlier data, I want you to make a histogram, and then underneath the histogram, using the scale, horizontal scale for our histogram, we're going to draw the box plot right underneath. Go for it. Whip out that paper. Draw, draw, draw.
Histogram and what?
With a box plot underneath using the histogram scale. Can't see? Come on, there's plenty of seats over here. We don't smell. Come on. We don't bite. You can come sit near us.
Are you sure about that?
No.
Well, I'm just scared of the people in the back that they might not see through my hair.
Oh,
Yeah.
that's cute. Come on. Okay, okay.
I'm like, okay, now I don't want to move.
Okay, I'm going to try to draw this too. Oh, good, you're joining us. Excellent.
Okay.
All right, so let's see. Okay.
Mary has more.
I should have made that fit better. Sorry, it'll be right back. There we go, that's better. I needed it to be a little more compact so I can draw. That'll work. One, 22. All right, there's my histogram and box plot to the best of my artistic ability. And I used the scale from the histogram to make my box plot. So I just want to do this to review some ideas about histograms, box plots, what they tell us about the spread of the data. Did I make any mistakes? Did I do a good job? That's what yours looks like too? Okay. Just checking. Box plot is called, it's a graph of what's called the 5-number summary. The 5-number summary is the min, quartile 1, the median, quartile 3, and the max. And so what we do is it's also called a box and whisker plot. So we make a mark based on some number line. Where are each of those numbers? The Q1 through Q3 make a box, and then we put whiskers heading out to the max and the min. And so you see histograms way more often, but box and whisker plots, like next to pie chart's the next most famous kind of chart out there. So what does it mean to be Q3? So our Q3 is what, 6.75. What does it mean to be Q3? 6.75. Yeah, 75% of the data is at or below 6.75 movies. Now, you can't watch 6.75 movies. Well, I guess you can. Yeah, you just not finish it. But here we're counting whole numbers of movies. So that means 75% of the people watch 6 or 7 movies is what we would interpret that as, okay? The median is 3.5, right? So that means half of the people watch 3 or 4 movies or less. And so that means 25% of the people watched between 3 and 7 movies, because each quartile marks a quarter. So a quarter of the people have to live in that region, or a quarter of the data have to live in that region right there. Similarly, a quarter of the data has to live in that region right there. So the third, now we got to distinguish, I'm using 2 different words here. A quartile is a position on a number line. A quarter is a region of numbers, right? So the third quarter is this space inside this box right here. Whereas the third quartile is that position on the number line, right? It's a point on the number line. I should use a different color, red. Point on the number line right there. So would you agree that my third quarter is very densely packed, right? 25% of the data lives in that tiny little box, right? So that's like living in a city, versus the fourth quarter is way spread out, right? It's way spread out. So just if we look at our histogram table, our frequency table, let's see, it starts at about 7. So that means all these numbers here, including some of those 7 up there, represent the fourth quarter of the data, way spread out. Whereas, let's see, what's our median is 3.5, which is just on the edge. So most of these 22 individuals right there are in the first half of the data, right? 50%, more than 50% of our data is in this column. Okay. No, that's a greater than. That's the greater than symbol there. Sorry, not a 7. Yeah, so this box right here represents more than 50% of our data. So the box plot tells us some information, the histogram tells us some information. Together they tell us a lot. And what we'll always find when we do a comparative box plot means we draw it with the same scale below or above. We'll see that anywhere we have tall stacks, we'll have narrow quarters. Anywhere we have short stacks, we'll have wide quarters to indicate the data is spread out. Okay. And so looking at data, it's nice to find, okay, about where is the middle of the data? We have two ways to determine that. We have mean and we have median. But we also want to find ways to talk about the spread of data. So there's only a couple of ways to pick the middle. Unfortunately, there's like a gazillion ways to talk about how spread out the data is, because every data set's different. So that means we need lots of tools to talk about it. Now we also have some other tools we haven't used on here. So we're going to mesh this graph up just a little more. So what I'd like you to do is on your X, your horizontal axis there, I want you to make a note of, let's see, where did I put them? The mean and the standard deviation. So I got those guys hiding over here. Okay, so I'll show you how to use standard deviation. So make a mark on the axis where you think the mean lives. So 6.4, so let's see, what color should I use? I guess I'll use black. There's 6.4 I think is going to be right about there-ish. So that X on my number line there marks the mean, the average. Okay, let's see, standard deviation. What does standard deviation mean? Anybody remember another phrase I used to describe standard deviation? Think. This is important. It's the average spread of the data. At least it's one measure of the average spread. What's deviation mean? But it's a very special difference. Yeah, it is a difference, but what kind of difference? What does deviation mean? We talked about your deviation in temperature watching movies the other day. Yeah, but what two numbers? It is a difference between two numbers, but what two numbers? What are we deviating from? The answer is average. So deviation is how far something is from average. Standard deviation talks about the average deviation of a whole group, the whole data set. Okay, so if I was to go one standard deviation right from the mean, let's see, so the mean has me at 6.4. So if I watched about 6.4 movies per month, I'm average according to this data set. Okay, AJ is above average. Okay, how far above average? Well, there's a couple ways we can talk about that. One way is to use the idea of standard deviation. So let's see, if I was one standard deviation above average, how many movies would I watch a month? I'm one standard deviation above average. How many? Nope. What's average? So if you watch 6.4 movies per month, are you average? Yes. Okay. Now we want to find somebody that is one standard deviation above average. How big is one standard deviation here? It's 7, right? Standard deviation is 7 here. So we would be adding, yeah, 13.4 means you would be one standard deviation above average. So find 13.4 on here. And let's put a mark on the axis. So that's going to be right about here-ish. That's one standard deviation above average. Let's go 2 standard deviations above average. So that'd be 14 plus 6.4 would be 20.4. So that would be about right here. Is 2 standard deviations above average. Let's go 3 standard deviations above average. 27.4. So 28-ish. That would be around right here, I think. Okay, so I'm going to mark those numbers. I'm going to have to use red because I'm running out of colors. So again, this would be 1. I'm going to call it 1 plus 1s Over here would be plus 2s standard deviations. This would be plus 3 standard deviations. Okay.
Oh, yeah.
My S's and 5s look the same. They do not. There's a slight difference between my S's and 5s. The 5s have this little straight part over there. Okay, stop picking on me. What about 1 standard deviation below average? So it'd be take 6.4 minus 7. That's going to give us like negative 1-ish, negative 0.6. Yeah, so that's going to be over here. So that would be minus 1s. Now, there's no point in talking about minus 2s because you can't watch negative 1 movies or negative 8 movies, right? How can you take away movies you've already watched? It just doesn't work. So sometimes we get numbers that don't make sense. But this is the middle of our data right there, right? Average says it's about 6.4. What did the median say our middle is? Ooh, that's a little bit different. Huh. I wonder, interesting. The mean is way bigger than the median. What causes such a thing to happen? Do you remember from our discussion the other day? What causes the mean to stray away from the median?
The outliers.
Outliers, yeah. Where are our outliers here on the right or the left? Yeah, these are our outliers over this way. Yeah. Okay. So how do you tell if something's an outlier? Like, where do we draw the line to say you're an outlier, but you're not? Okay. And there's a few different rules for that. I'm just going to go over one of them. One of the rules is if you're more than 2 standard deviations away from the mean, you're an outlier. So in this case, let's see, our second standard deviation from the mean is right here. So that was around 20.4. So anybody that watches, according to this data set, 21 or more movies, that's unusual to find people that watch that many movies a month according to our data, okay? So some of the people I interviewed are unusual compared to the rest of the group I interviewed. More than 2 standard deviations away, yeah, that makes something an outlier. So let's write that down. So that's just one definition. There are others out there. We're not going to worry about those. One definition is more than 2 standard deviations away from the mean.
Not doing more stuff that way. Letting you know.
Okay. Now we could be 2 the other way. Things can be unusually low. Okay. Now for us, because we get negative numbers when we try to go 2 standard deviations to the left, we don't have any outliers to the left. But outliers can be unusually large or unusually small. Okay. Like if we looked at heights of people, I think we would be able to visually recognize people that are more than 2 standard deviations above average. We'd say, wow, they're tall. I wonder if they play basketball, right? Or we'd notice people that are shorter than average, right? Are they an adult, right?
Wait a minute.
We didn't even calculate how far you're from average on height. We could look at that another time. But again, it's defining an outlier. There's a couple of different ways to do it. And usually if people want to be sure they have outliers in their data, they use multiple ways to double check. Okay, because they don't always line up, but that's just one way. Because otherwise you're just saying, hey, that looks kind of far from average. But being far from average is part of it. All right, I think that's about all we can do. We get a lot out of that one little thing there. Okay, let's do something else. It's 12:30. All right. Let's look at a couple of homework problems. There's one thing I haven't gone over yet, and then there's some analysis that I wanted to go over together from the homework. So where did I put my homework? There it is. Okay, no, the dog did not eat my homework. Thank you for asking. Okay, so let's see. I thought number 9 was exciting. So number 9 is about a weighted average. So I just want to talk about what a weighted average means. Let's see, did we talk about this earlier in the course? I have a vague recollection that in some other chapter we talked about weighted average. Oh well, talk about it now. So weighted averages are used a lot for like class grades, like your homework's worth 25% of your grade and tests are worth 50% of your grade. Anybody ever read a syllabus that had that kind of stuff in it? Yeah, so that's weighted averages. So that means each thing has a weight and then we have to apply it. So I am going to steal these numbers into a spreadsheet. Oh, I guess I want all of it, don't I? So I'm going to copy, and I need a new spreadsheet. Where is my drive? What are we struggling with, AJ? Oh, yeah, I have that problem some days. It's artistic skills for most people come with practice. Okay, sheets. Okay, so one thing I'm going to do is I'm going to take this data and I'm going to make it go vertical instead of horizontal. I think I can do that here. There it is. Okay, so these are the scores here and these are the frequencies. Somehow that makes me feel better having it oriented that way. And let's just hide those. Let's see, where is hide here?
How many numbers are there?
I lost track. Oh, here we go. Hide rows. Okay. So the scores, people can have a score of a 0, a 1, a 2, a 3, a 4, or a 5, right? So that's our data right there. How many zeros were there? 2 people got zeros. How many ones? None. How many 2s? There were 4. Okay. So to do an average of this, I could write out, oh, that was weird. Let's copy that back to my spreadsheet. All this screen switching, there we go, isn't making anybody dizzy. Raise your hand if it is.
Yeah, it's making me dizzy.
Okay.
I'm trying to copy the numbers. Huh? Well, yeah, that too.
All right. Can you get those copied now? Do you need glasses?
Yes, I told you that my glass is broken.
Oh, I'm sorry.
How many for 3
There are 4 3s,
and 4?
2 4s. Okay. So looking at this data, one way to come up with the average would be to go, there are 2 zeros, right? And there are no 1s. Oh, can't write anything there. Let's see, how many 2s are there? So I could go 2 plus 2 plus 2 plus 2. So I could just start listing all this stuff out, right? But don't we have a trick in arithmetic that repeated addition can be written a little easier? Not exponents, easier. Multiplication. Yeah, so this really, I could just say, hey, there are 4 2s. Okay, so backing up a sec, I could say, hey, there are 0, let's see. Right there.
Oh, okay, I got you. For whatever reason, I was seeing it like.
So these are the scores. Those are the scores in that column, right? And this is how many times each one occurs. You got it now? Okay. All right. It's Friday. We'll get done eventually. Okay. All right. Let's get back. All right. Take a deep breath. Release it. There we go. Okay. So looking at this table, I can say I have 2 zeros and I have no 1s and I have 4 2s, right? And I have what? 4 3s and I have 2 4s and I have 3 5s. Altogether, how many numbers do I have? Well, according to the frequencies, I have 2 and none and 4 and 4 and 2 and 3.
Okay, you're making me a same
Oops, wrong color. Get it? There we go. So again, these are my frequencies. I'm counting how many of each score we got, because that's a more efficient way to do it than list each number one at a time. That's the whole reason we make frequency tables. It's more efficient. And then down here, these are those same frequencies. Because if I add up the frequencies, don't I get the count for the data set? Yeah. So this is an average. It's called a weighted average because each number in my data set occurred a certain amount of times. The amount of times it occurred, those are the weights. So frequencies are weights for each number in the data set. So that's a weighted average. And the homework question says, look at the frequency table and come up with the average. There's two ways to do it. Based on the frequencies, list each number that many times, then add them up. We don't want to do that. We want to do a weighted average. And Ian is dying to ask, can a spreadsheet do a weighted average? And the answer is yes, it can. Thank you for asking that. Yeah. Okay. So before I have the spreadsheet do it, whip out your calculators, calculate this weighted average for me. Okay. Yeah, I get 43 for the numerator. Yeah, and notice how I did it. I multiplied this column times that column and made a third column. That's one trick we can use in a spreadsheet. And then I have to add up these guys too. So 2 and 4 is 6, and 4 is 10. That adds up to 15. Okay, so my average should be equal to 43 over 15, which is going to come up to some crazy decimal. Okay, so this equals 2.8666, and there's a whole lot of sixes. So usually when we calculate statistics, we go one more decimal than the data has. Well, our data is a whole number, so that means going to the 10th would be sufficient here. So we could say that the average here is about 2.9. Anybody else get about 2.9?
I did.
Okay. That's called a weighted average, right? And it's the same thing as a regular average, but the regular average means you would have each item listed individually, which is a waste of time here. Yes, right, it just compresses. A weighted average just compresses the data, but it's the same average. So a weighted average is just an average, but you do it that way because the data was presented in a way that made you want to do a weighted average. That's all. Sometimes it's forced upon us, like a weighted average for grading. That's a little different, but it's the same idea. All right, so now I'm going to do it on the spreadsheet, and I'll show you two different ways to do it. Let's see, where's my spreadsheet? Here? No, here? Ah, there it is. Okay. So one way to do it is to make a column of those multiplications. So you could come over here and call it whatever you want, product, scores times frequencies. I'm going to call it product. And then you just say, I need to know what is this number times that number. And then you just fill it down. Oops, did I do plus? No, times. And then I fill it down. And then I need to add those up, right? So then I do a sum on that. Yeah. It's a lot less typing. So, and the cool thing is on the computer, you can just highlight the data and paste it into a spreadsheet. Copy and paste. I'll show you again how I flipped it. So let's see, oh yeah, I want to sum these guys. So that gives me my numerator, right? How do I get the denominator? have to add up the frequencies for the denominator. So then I do another sum here. Okay, so I have my numerator here, I have my denominator there. Am I ready to find my average? Yeah. So to find the average, and I'll share this spreadsheet with everybody. I just take my sum of the products and I divide by my sum of my frequencies, and there's the average that we got earlier. Okay. So you'd think, since a weighted average is really a very common thing, there might be a quicker way to do it. Sort of. So I'll show you the quicker way to do it. So here I had to take the sum of the product, right? Okay, well watch this. I'm going to come down here and I'm going to type equals S U. Ooh, what's that at the top? Hey, there's a formula called sum product, which allows us to bypass that extra row. And so what the sum product says is, okay, give me your first row or column of numbers. Okay, here's my first row or column of numbers. Then it says, okay, give me a comma and give me any other rows or columns of numbers you need to. And so there's my 43. Yeah, you could use it for multiple rows instead. So I could go back to the original display of the data and use it that way. Yeah. And then right in the same spot, I can just say, okay, after I do the sum product, just divide by the sum of the frequencies. So there's no single formula to get a weighted average. You have to combine sum product and sum. And so then I come over here and say, okay, add up the frequencies for the denominator, and bang, there's the average. If I had to take the sum product, oops, I'm having trouble here. There we go. Okay, of my data. And so that would be, in this case, the scores, comma, and then the frequencies. And then that's what I want to do the sum product of. And then I just divide by the sum of the frequencies. So that's how I calculated it. For the data we're working with, they're small enough, you can do it with a handheld calculator, but in reality, you're gonna have bigger data sets, a lot more numbers, and so that's the way it's done right there. A lot of, if you're gonna do this often in your life, then whatever company you work for will buy a program that does all this quicker with a push of a button. But spreadsheets were designed for business type stuff, not necessarily statistics. That was all kind of an afterthought that people started putting all these extra commands in. So, but you can still get the job done. Okay, so a weighted average, very important. Do you remember what the button looks like on Excel or Sheets to get quick formulas? It looks like an E, but really it's a Greek S. It's called sigma. So that's the Greek sigma.
You want to say Greek E?
No, it's not an E, it's an S. It's a Greek S.
Greek S.
Okay, it's the capital Greek S, thank you. Yeah, it's capital, not the lowercase. And in math, in computers, it means sum. Okay. So I'm gonna use that to write the weighted average formula in just a slightly different way, just because this is a math literacy class. That means we have to use some math symbols occasionally. So the math symbols you'll often see for a weighted average. Often you'll have a table and the scores, you know, they might not be scores, they might be weights, they might be temperatures. They're usually called your X values. And weights are usually called frequencies, right? So we have a whole bunch of numbers, you know, 7, 9, 15, 22, whatever those numbers are, and how often they occur. 1, 5, 2, 3, okay? And it could be a really long list. Depends on the data. Okay. The weighted average is always going to be the sum, right? Remember that means sum, of the product, right? Of the number and its frequency, right? To do the weight, you have to take the weight times the number you're working on. X value is the number, F is the frequency. And then you divide that by the sum of the frequencies. And this is what I typed into Excel. I typed in a sum product and I divided by the sum of the frequencies. And this is how you calculate a mean from a frequency table. What's that? That's the point.
Okay now.
Okay. All right, couple more problems to look at. And we're going to call class early today. How can you say yes? You're paying for this. That means you're willing to get less than you paid for. Like when I go to Walmart and I go to buy a bag of chips and they take some of the chips out, but they're still going to charge me the same amount of money, I'd throw a fit. I'm just teasing you, nothing. I'm just making stuff up. All right, so I'll share. Ooh, that's weird. I don't know. I'll share this weighted average sheet with y'all in a little bit. Y'all.
Have you ever showed them your Boston accent?
Rhode Island. It's different than a Boston accent. Please don't confuse the two. Them's fighting words there. Yeah. Actually, I grew up in Rhode Island, so I spent like 22, 23 years before I moved out west. And I worked hard at losing my accent. My real name is actually Gary Paca. And I had to practice really hard to get those R's in there. Gary Parker. It was hard. Living in Alabama for a little while helped. That made me much more conscious of my accent. Okay, let's see. Other problems I wanted to look at. That was number 9, right? Let's make sure we got it right. Ooh, I didn't show how to do median. Okay, mean, and I don't know how many decimals they want. I'm going to go for 2.9. Is that what we found? 2.9-ish? Okay. As far as the median goes, we just need to know how many numbers are in this set, right? And what did we calculate? There were 20, where'd it go? 15, sorry. There were 15 numbers in there. Okay, so then we have to, on what number's in the middle of 15 numbers? Of course we do. 15 plus 1 is 16, divide by 2. The 8th number is the median. So all I have to do is look at the table and say, okay, where is the 8th number going to live? Well, there's 2 here, 6 here altogether, 7, 8, 9, 10 over to here. So where does the 8th number have to be?
3.
It's got to be one of those 3s, doesn't it? Yeah. So once I know that there's 16 numbers altogether from the frequencies, or 15, sorry, the middle number of 15 is the 8th number, I just count over. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's in here. It's the third, one of those 3s right there. Okay. I could similarly find the quartiles by just counting across here. Okay, let's do that just for fun. So I think the median is going to be one of those 3s. Let's find the first quartile. Okay, let's see, quartiles. Do you remember the locator method we talked about the other day? It's in the book. One of the homework problems says use the locator method, not the computer program functions. So the locator method says take the number of items to find the location of the first quartile, multiply that by 25%. Okay, so let's see, 15, somebody with a calculator, what's 25% of 15? Like 3.75-ish on a good day? Is it a good day? 3.75, okay. So do you remember what the rule said to do if it's a decimal? You round up. Even if it was like 3.1, you would still round up to 4. Yes, that's super important. Yes. So we're going to call that 4. So this means the 4th number in the list has to be Q1 according to the locator method. Okay, just before I do that, I have a what if. What if the locator said it was exactly 3? What would we do with that locator? What does the locator method say to do if the location comes out to be exactly a whole number? Nope. Locator method says take that number, add it to the next number, in this case the 4th number, and average them. Yeah, so if the locator comes out to be a decimal, you always go to the next highest whole number. If the locator turns out to be a whole number, then you take that position and the next position and you average them. I would have to take whatever the third number is, add it to the fourth number, and divide by 2, right? So for this data, if we followed through the what if, where'd it go over here? There it is. Let's see. 1, 2, the third and the fourth number happen to be both 2s, so that doesn't change much, right? So let's say maybe it said it was 6. That means grab the 6th and 7th number. The 6th number would be a 2. The 7th number would be a 3. So that means I would have to average a 2 and a 3 at 2.5 to get the first quartile. Okay. So there's a homework question and a quiz question that says use the locator method, which means you're going to want that page of the book available because it's a little tricky. Okay. Can you use that page in the book on the final? Answer is yes. That's just fine. You can have the locator method written down. So if we were looking for the fourth item, what is the fourth item in this list in order? Is it a 0, a 1, a 2, a 3? It's a 2? Yeah, there's 2 numbers here. There's 4 numbers here. That means there's 6 numbers collecting all the 2s. So the fourth number has to be one of those 2s. Yeah, okay. All right, we got time for one more, and then I got to take a class for a sick teacher. That's one reason I'm letting you guys out early. How about number 12? I thought was cute, and so is 13. I think 13's.
Math equations cute?
Yes. Okay, so this is a good one right here. So let's blow this up a touch more. All right. So here we're going to use standard deviation along with a mean to try and make some kind of decision comparing 2 data sets. So we have one class that had an average of 8.3 with this average spread, right? Standard deviation is one way to measure average spread of 1.2. The other class had a average of 7.7 with a standard deviation of 0.4. So what I'd like you to do is on a number line, we're going to mark this information. And then we're going to try and say, you know, which class did better, which class was more consistent. All right, so I'm going to steal that information into my spreadsheet here or my notebook. I'll be right back with it. Oops. All right. Okay, so there's that data. The data is more tightly packed, right? So that means the scores are more consistent, right? That's a good one. But it's kind of fun to look at this on a number line. So we're going to draw a number line. And then let's see. So remember, the mean is our middle, and the standard deviation tells us how to jump left and right away from the mean. So that means we're going to have to be jumping, you know, a little over 1 to the left and right of 8. Right? And usually we take a look at like 3 standard deviations on each side. So 8, 9, 10. So I want to go out to like 12 on my number line here. And I don't really have to go all the way down to 0. Let's see, 8 minus 3 is what, 5. So maybe I'm going to go from like 4 to 12. 4, 5, 6, 7, 8. Uh-oh, am I not going to make it? 9, 10, 11. All right, we'll just move these guys all over a little bit. Soon we'll have paper that does this. Oh, we kind of do, tablets, huh? All right, so 12 is over there, a little bit off, but not too bad. So then I'm going to mark class A above and class B below the number line so I can kind of make sense of it. So we'll put A information up here. So let's see, A had a mean of 8.3, so that's right about here, I think. And the spread is 1.2. So if I go 1.2 to the right, where does that put me? 9.5. So right here. And then we jump 1.2 again. 10.7, about here. And then 11.9 would be the next one. So that's going to be about over there. Okay. And this one is my mean, right? Mean, by the way, has the symbol X bar, if you read the book. X with a bar over it means the mean. And we can go the other way. We can subtract 1.2. So that'll take us down to 7.1, about there. And then, uh-oh, now here's where it gets tricky. I got to borrow. Thank you, 5.9. And then 4.7, about right there. So from the mean, we can jump either direction. So that shows the center and spread out to 3 standard deviations. Can data be farther than 3 standard deviations? Oh yeah, it can. It's rare, but it can happen. Okay. All right, so then we'll mark the other one underneath. Let's mark class B underneath. Okay, class B, 7.7, so that's about right here-ish. And then here we're only jumping by 0.4. So 0.4 to the right would be what? 8.1. So about here. And then 8.1, 8.5, about here. 8.9. Yeah, so this class, the scores are pretty tight. And again, this is my X bar, my mean for that data set. And then we can go 0.4 the other way. So would that take us to 7.3, about right here, and then 6.9, about here, and 6.5, about here. So here's jumping 3 standard deviations to the left. And it's unusual to find scores below 3 standard deviations or above standard deviations. Those are outliers, right? And earlier I said 2 standard deviation is usually the mark for outliers. Okay. So usually what usually happens with data, you'll find about 95% of your data is going to be within 2 standard deviations, and about 99% of the data will be within 3 standard deviations. So we're pretty safe that we caught all of the students here. Okay. So we're trying to predict which class did better. Well, class A does have a higher average, and there's some people that got higher scores than anybody in class B. There are also people that got way lower scores than anybody in class B. So class B, definitely their scores were more consistent. And then now we just have to, it's a value judgment as to what does better mean, right? Well, a bunch of people got higher scores in class A, but people got some lower ones too. So then we have to attempt to answer those 2 questions. Which class scored better on average? Well, if we're talking about average, A did better, right? If we throw in the spread, well, B was more consistent and their average was close. So I would have to say, you know, B. So then here, B was much more consistent because they had a smaller standard deviation. Okay. All right. You guys get to have fun with statistics. So if you haven't been doing your homework, please use this next half hour to go do your homework and go in the other room and you can ask each other questions. I promised a sick teacher I would take their class for the next hour, but I will be back around 2 if you have any questions. Otherwise, email me. Don't forget, homework's due Saturday night. So if you don't think you're gonna get it done, apply a late pass now. If you don't use the late pass, you can always ask for it back. Did you send me what you're supposed to send me yet, Ian?
Oh my God.
Please don't forget that any longer. All right. And Ben, do you have any questions out there?
If you get time, would